So this is what I've been using to probe for some time now. It has an aviation panel mount socket at the end, and when I required it I would plug it into this aviation panel mount here. There are two ends. One is bolted onto the aluminium plate, and this is 1.5 millimeters thick, and there's a crocodile clip on the other end, and this relays back to the control board. This is connected to the ground and this is connected to the signal. And when I wanted to use it, say for example this was the material I was planning to cut, and I'd set my file up to cut from the top of the material down and 0 was at the top of the material, I would take the crocodile clip and hold it onto the bit. I would toggle down a little bit until the bit was just hovering above the plate, and I would do a G38.2 command where the probing cycle would stop upon contact. So essentially when the circuit is made, the controller recognizes that as being the part at which the probing cycle stops. If I am on G38.4 and I press probe, I get an alarm and I'm not able to probe. I have to unlock that, change that back. So here goes. That's pinching it ever so slightly. And then I would write a very simple command, G92 Z1.5. So it's set that point there where the tip of the bit is touching on the aluminium 1.5 millimeters above the 0 of the Z. Press enter. I'm just going to scroll up so you can see the Z coordinates here. So when I press enter, that changes to 1.5. Go back to the control tab, I raise the spindle up. I can then take the plate away. So if I press move to origin, the bit is going to drop down and rest on the material. Now I had it set to Z25 because I actually use a different method to probe now. So if I press that, it moves up. This is a nice quick way of probing, and something to mention actually, since I redid my controller, I actually wired in the ground from the spindle, so I don't even need to use this crocodile clip anymore, but most people would, because they wouldn't mess about with their spindle in this way. But there is a disadvantage to probing in this method, and that's if you're changing tools, and especially if you're working from the center of the material that you're milling. As you start to cut stuff away, you may not have your original height to then probe from. So being able to probe from a separate location and use that as a reference point to come back to your cut actually makes a lot more sense. And that's why I've added this button here. If I pull the touch plate out, I plug in this other probe. I can show you how this works. So this is just a button, in the same way that this emergency stop is a button. This has a normally open section which are removable. These can be screwed on and off, while the one I'm using for the probe is actually normally closed. What I would say is the top is relatively flat compared to one of these e-stop buttons where it's a little bit domed, so you want to use something that is as flat as possible. And it had crossed my mind to maybe glue some material on here and then mill that flat as well, just to improve that surface. So there's nothing fancy, these are quite cheap and they're pretty reliable. When starting up your CNC machine, you should always home all the axes. This should always be the first thing you do, as it sets the machine position to 0 for the X, Y and Z, which you can then use to reference your jobs from. It also means if for some reason you lose your cutting position, you can home and restart your job by finding your origin position from the machine position. Once it's done that, I can see my machine position is roughly 2.5 millimeters from where the sensors were triggered. Now, I should also mention I've got loads of macros here that I've been setting up. Some don't work, like move around margins. I've never been able to get that to work, and I think that's more to do with the controller. And I've got a G0 probe and bit changing location. I'm using a G53 command, which stands for Coordinate System Select, and will move the different axes based on the machine position. The way I created this macro was to manually move the bit after homing to the button and write down the MPOS coordinates. I then completed the code G53 G0, X minus 8.5, Y minus 494.5 and Z minus 10. If I move the button, I'll have to rewrite this macro. And if I press this, you'll see where the spindle moves. And it's basically going to hover above that button. Now from here I can do a probe. Now there is a tool probe setting here, but I've never quite been able to work out how to get this to work. So I just wrote something a bit simpler for me to follow. And if I go back to the probe, I'll explain how that works. So the first thing I need to do is go to the Pro command and change that to G38.4. I then go back to the Control tab and drop the spindle down just above the button. So I've centered this and it seems pretty good. I've used it again and again, and from that position I can set the Z to 0, and I do that because if you look back at the probe, my probing distance is only -10. I didn't particularly want to start a long probe manually from the top of the home position Z axis, because that would take quite some time. And what's happening here is, while the previous touch plate essentially worked based on a normally open connection where the contact of the bit and the plate closed the circuit, this is the opposite way around. So as it says in the command there, it stops on loss of contact. So there's a current being passed through. When the bit pushes the button, it opens the circuit, and then the probing cycle stops. Press probe. So now I know the point at which the button gets pressed is 77.337 millimeters from the machine 0. This does vary a little, but what I'll do later is perform a repeatability test to show you what the variation is over multiple bit probe cycles. Before that, I'll go to my macros, and there I can select either to set the Z height by itself or to set the Z along with the X and Y, which I worked out to be the corner of the wasteboard. So if I right click on that macro, you can see the full command. And I've written a note to myself to remind me that the Z must be manually located and inputted in if wasteboard is resurfaced. So each time I make the surface of the wasteboard lower, I need to make sure I find that Z height. And the way I do that is, in this case I would press 0, the Z, I would move the bit up, I'd move across, and I will toggle down so that the top of the bit is just cutting into the MDF surface, making sure the bit clears the material that it will eventually cut. Now, differently from the way I set the probe and bit changing location, this time I need to look at the work position and input that into a G10 command. In this instance, I'm just moving back to the probe and bit changing location, conducting another probe cycle, and to make my life easier, I'll just press the macro button. But I'll explain what the macro is doing. G10 allows users to set the tool offset and or a workplace coordinate and or tool temperature. I don't have to worry about tool temperature, as that's more for 3D printing. P stands for the tool number. In my case, I only have one tool. And L stands for the offset mode, and I'll be using L20 command, which adjusts the current workplace coordinate offset so that the current toolhead position has specified coordinates, and then X, Y and Z are those specified offset coordinates which happen to land on my surface wasteboard roughly on the bottom right corner. Now, the problem I had is because my probe is below the surface of the wasteboard, depending how this is written, you don't particularly want to move the X and Y axes first. You want to move the Z so that you're clear. There's less chance that you'll hit your bit against anything. Okay, and that seems to have worked. So now the bit is above the 0 of the X and Y, and it's 25mm, so it should be clear of any material. I'll be mainly working with things up to 18mm anyway. While I'm here, I'll also talk about some of the other macros. So I found it quite useful to have a home for X and Y and a homing button for Z, if in case I need to move the bit quickly away from something. And the other thing I did was create a warm-up spindle macro which lasts for 4 minutes, and it takes the spindle from various speeds for various amounts of time. It's an M3 G04 command, and the P30 stands for the amount of time. And if you're working in a garage and you don't use your machine every day, the spindle can get cold and the grease inside it can gunk up, and it's just a good habit to warm up the spindle before you do any jobs, and that just means you prolong the life of the spindle. It would be nice if you could create options to have a choice to press something in case you accidentally press it. So for example, I could press this once and then I get prompted with a message saying, do you want to operate macro 7? And I'd say yes, because in a way these buttons, if you accidentally click them, you may end up flinging your machine somewhere. So I'll just show you this button working. So for this method to work, you do need to surface the wasteboard so it's all nice and even, and that new position can find the wasteboard and cut through your material anywhere across the area. Okay, so now I'm in my CAM software, ArtCam Express. I keep saying whenever I have a screenshot of this is that this software does not exist anymore. You can't buy it. It's been bought out by Autodesk, and they've essentially taken the best bits and ran it into the ground. So if you do want to use a software where you're not kind of tied into a subscription cost, I would recommend VCarve, but I have yet to move to that software, but it looks pretty good. But essentially what I'm going to explain about the next method of setting up your files with the method of probing that I demonstrated, it should be the same for both softwares. Now I've created a canvas. This happens to be 600mm square, and if I go to toolpaths I can set up the thickness of the material. You can see the material thickness has already been set to 12, and the thing here to point out is the material Z0 and how this relates to your files and what you're cutting. So because I've set the 0 based on the probing sequence I've just done, and the wasteboard height is 0, the material 0 height in the software should be at the bottom. There is an advantage for doing it this way, and that is if I accidentally put down a material thickness that is bigger than the material that I'm actually cutting, when I go to run my job I will just start with the bit hovering above the material, and it would take several passes before it plunges through into that material. If you work with the probe method that I showed previously, where the 0 is at the top of the material, if you've made a mistake and you cut 18mm but you placed a 12mm board down, you will eventually cut through your wasteboard. So there's one very practical reason why this method of probing and setting up your files is advantageous. Okay, the other thing I forgot to mention was setting your origin position. So in this window here you can see the canvas size or the material size, and if I click either in the center or in different corners, the origin position changes. So for my CNC machine, the way I've built it, it happens to be the bottom right, but depending on how you prefer to work with your machine and set up your files, you may use a different corner. And if you're working with the previous method of probing where you set the 0 on top of the material, I found when I first started building CNC machines and when I used to use the X-Carve, because of the inherent flaws with the machine, actually setting your jobs based on the center of the material made the error proportional from either side, and actually working from a corner would amplify those errors. But with my machine, it's rigid enough and accurate enough to be able to work from one origin point, which is determined by probing from a stationary tool bit probe. This is going to be a repeatability test. What I've done is home the machine. I've now moved it over my probe location. I'm going to probe and then look at the position of the Z-axis when that is triggered. I'm then going to repeat that and see if there's any variation. Just going to rotate the bit around so the point is another part of the button and see if that makes a difference. So while that's doing that, I'm going to say the things I normally say at the end beforehand. I'm sure if you're still watching this until now, you must have found it interesting or you hate me. But either way, a quick note to say I'm going to follow up this video with another one about the macros, as I've made some changes to what I'm using and I don't want to re-edit this video, so stay tuned for that. Additionally, if you have anything to share about how you run your jobs or do tool changes, do let me know in the comments section below, as I'm pretty sure there's more than one way to CNC a cat. Okay, here are some of the outputs I got. I did 1, 2, 3, 4, 5, 6, 7, 8 cycles, and in fact I did see some variation, but I also did rotate the spindle collet a little bit, and I don't think it's something that I'm going to notice, especially along the Z-axis. And the most important thing is that I don't lose steps on the Y and X, because that would be obviously a lot more noticeable. For softer materials, acrylic, MDF, Weezer and so on, this is absolutely fine. So there you go, you can make a touch probe with a simple momentary button.